Hi there, welcome to my channel Maths SL. I'm speaking Thaqib Latif. This is November 2018 question. Is a very interesting question. I would like to upload the video about this question. So the question says the graph of g of x is equal to x power 3 plus bx square plus cx plus d is sketched below. The graph of g intersect the x-axis at -5 and 0, which is here, x-intercept, and on P. So this is the also x-intercept as well as turning point, and the y-axis at 0, 20. So this is a y-intercept. P and E are turning point of G. So this is the turning point. P and R are the turning points of G. So that this is R is one turning point and the second turning point is P. So this is the information of the sketch. So first question is here, show that b is equal to 1, c is equal to -16 and d is equal to 20. So we need to find the equation of the cubic graph. So you can see clearly this is a root form, because we have 3 x-intercept. So by the turning point we're going to count 2 x-intercept, the turning point as well as x-intercept, then we count twice. So this is the root form because we have 1 x-intercept here and 2 x-intercept here. By the turning point we count twice. So this is the root form. G of x is equal to, this is x is a liar, it's going to be x plus 5, and x by the p is a positive, we're going to write negative x I denote with x1 square because we're going to count as twice. Now in root form always then we substitute the point on the graph. So we, in this case, we have y-intercept which is 0 and 20, x value 0, y value 20. So it's going to be a 20 is equal to, place of x is 0 plus 5, and this is going to be a 0 minus x1 square. Now I solve, this becomes 5 x1 square. So we left with this one. Therefore the x1 square is going to be equal to, both sides you divide by 5, is going to be a 4. So the x1 going to be I take the square root for the 4 square root, outside positive and negative. Therefore the x1 going to be a positive and -2, but we're going to use the positive 2. Therefore x1 going to be a positive 2. Why? Because the p lies on the positive x-axis. So this is here going to be a positive 2. This is my turning point and x-intercept as well. So now I need to put back into the here x1 value, and then I will solve further. G of x going to be is equal to x plus 5, and we got the x1 now, x positive 2, we're going to say -2 square. Now we need to FOIL this one. So x plus 5 from here is very easy. So I'm going to open up the perfect square formula, x square minus 4x plus 4. I'm going to further solve now. It's going to be, I'm going to multiply x plus 5 into this x square minus 4x plus 4. So the answer going to be therefore x power 3 and minus 4x square plus 4x. Now I multiply positive 5, so plus 5x square and minus 20x and plus 20. So I'm going to further simplify. X power 3, this become positive x square and minus 16x and the plus 20. So after I simplify, so the g of x I got, this is the equation of the cubic graph, and now I can see we need to show the b is equal to 1. They will show b is equal to 1 here, and then we need to show c is equal to -17. This is the c is equal to -16. We need to show d is 20. There we go, d is equal to 20. So b is equal to 1, c is equal to -16, d is equal to 20. So we proved. 9.1.2 second question is easy. Calculate the coordinates of P and R. So you're looking P and R, so the turning points. So the turning point, we need to take the first derivative, and then we have to set it equal to 0 and find the x values, and as well as y value. To find the y value, we have to substitute into the original function. So first of all, g of x we have. So g of x, this is g of x. So first derivative, I need to take 3x square plus 2x minus 16. So this is the first derivative. Now I need to, first derivative must be equal to 0 to find the turning point. Plus 2x minus 16 is equal to 0. Now I need to factorize. So 3x plus 8, after I factorize, x -2 is equal to 0. If you can't factorize, then you can use the quadratic formula. Therefore the x value is going to be equal to -8 over 3, or this side is going to be x is equal to +2. So we got the x value of the turning points. So to find the y value, we will substitute back into the original function, and then we get the y value. So we need to substitute x equal to -8 over 3 and x equal to 2 into the original function to get the y value. So I substitute x equal to -8 over 3 into the original function. I get the y value, which is 1372 over 27. So the r on the negative section, so therefore the r is gonna be a -8 over 3 and 1372 over 27. So r on the negative section, so therefore r is gonna be -8 over 3 and the y value 1372 over 27. So this is the coordinates of r. So we're looking at p. So I'm gonna substitute x is equal to 2 into the original function here to get the coordinates of p, the y value of p. So I substitute 2 into the original function to get the y value 0. Therefore the p coordinates gonna be a x value 2, y value 0. So we got the two turning points. Now the question says, is the graph concave up or concave down at 0, 20? Show all your calculation. So we need to see the graph concave down or concave up at this point here. So we need to apply the second derivative to check the graph is concave up or concave down. So the second derivative is going to be a 6x plus 2. Now we're looking now at x equal to x value is 0 here. Must remember the y, this is a y-intercept, x value is 0 here. So the g of 0, we're going to substitute 0 place of x. So it's going to be a plus 2. The answer I solved, the answer is +2. So the +2, the answer comes +2. So which means therefore the graph is concave up. Concave up. The answer is positive, so which means the graph is concave up. 9.2, guys, this is very different question, and I'm gonna solve two more questions like this to explain to you this concept. He say if g is a cubic function with g of 3, which means x value of 3, and first derivative of 3 is equal to 0. So which means x-intercept and the first derivative is 0. Turning point and the x-intercept, they are together, so which means we're gonna count as twice. And the g of 0 is 27, which means this is y-intercept and this is x-intercept as well as turning point. And now he says the second derivative greater than 0. when x less than 3. So which mean less than 3, the second derivative will be positive and second derivative will be negative for greater than 3. So the greater than 3 will be negative. And now you should draw a sketch graph of g including all relevant points. So we need to sketch this graph. So must remember, so we got the turning point and as well x-intercept as well. That's gonna be x value 3 and the y value 0. And then we have y-intercept, and the y-intercept is x is 0, y value 27. And now second derivative will be positive when x is less than 3, and the second derivative will be negative when x greater than 3. So I'll show you how. So this is my y-axis, this is my x-axis, and now I'm gonna sketch the graph. So we only got x-intercept and y-intercept. First I always sketch the graph and then I plot the points, or you can plot the points first and then sketch the graph, simple. So there is a positive 3 here, and say this is a 27 here, y-intercept. Now the graph less than 3, which means the less than 3 is this way, less than 3, and the greater than 3 is this way. So which means the graph is concave up when x less than 3. So it's going to be concave up. So this is my graph, concave up when x less than 3. You can see this is concave up, and concave down when x greater than 3. This is concave down. So I'm going to show you one more question like this. I told you I need to explain this concept. Let's do 2 questions more. That's not a part of 2018, but that is Free State and Limpopo 2023. Our September exam, trial exam questions, I would like to also add into this video to explain this concept properly. And the learner are struggling. That's why I want to show you 2 more questions. And look here, this is a ax square. Oops, can't see properly. This is ax square, but ax cube. This must remember, this is ax cube plus bx plus cx plus d. So this is the standard equation of the f of x. So there is a f of negative 2 and f of 1. So the f of negative 2 and f of negative 2 is equal to f of 1 and equal to 0. So which means at x equal to negative 2 and at x equal to 1, y value 0. So these are the x-intercepts. So they are the x-intercepts. So we need to write the information first before we solve this question. And the first derivative, this is the first derivative now. So the first derivative, first derivative at x equal to 1 and the first derivative at x equal to negative 1, they are 0. So the first derivative at x equal to 1 and the first derivative at x equal to negative 1 equal to 0. So which means they are the turning points, because the first derivative equal to 0 means they are turning points. Now this one is a f of negative 1 is equal to 4, which means f of negative 1, which is x value negative 1 and the y value going to be equal to 4. This means x value negative 1 and y value is equal to 4. So which means x is negative 1 and y value 4. So this is going to be a turning point. Why? Because first derivative at x equal to negative 1 is 0. So these are the points of the turning points. So and the second, this one is f of 0 is equal to 2, which means f of 0 is equal to 2, x value is 0, y value is 2. So this means this is a y-intercept. The last one, this is important one. First derivative, this one, first derivative. He said the first derivative less than 0, which means the first derivative is negative between -1 and +1. So between -1 and the +1, the first derivative is less than 0, mean is negative. That you must remember. Now we need to draw the graph, sketch the graph. I'll show you how. So this is my y-axis and x-axis. I'm gonna draw the graph now. So I always sketch the graph first, then I plot the points. So in this case we need to first plot the points and then we can sketch the graph, because we need to obtain this information. So first of all, I'm gonna display the x-intercepts. So I've got two x-intercepts there. X equal to -2, say the -2 is here, and x equal to 1, say the +1 is here, and these are my x-intercept. Now the turning points. So must remember this first derivative is 0 by the +1, so which mean here gonna be a turning point because first derivative is 0. This is my turning point here, and at x equal to -1, the turning point also 0, and we have the turning points. This at x equal to -1, y value is 4. So the -1 may be somewhere here, and if I can see there's gonna be a -1 and +4. Between -1 and +1, the first derivative must be negative. So which means between -1 and +1, the first derivative must be negative, so the graph must decrease. So obviously we start the graph from here first, and the y-intercept we have 0 and 2. So somewhere here, this is my y-intercept, x value 0, y value 2. Now I can sketch the graph. So I'm going to sketch the graph first, increasing, and from this turning point till the +1 is decreasing, and then from here again obviously gonna increase. So this is gonna be my sketch. That's why you can first sketch the graph and then you can plot the point, or you first plot the point then sketch the graph. Don't need to be according to scale. They just want to see, understand the concept. So this is going to be my sketch of the graph. You can see between -1 and +1 the graph is decreasing, because he said the first derivative must be negative, and the first derivative is negative here. So this is the last question about this concept, and as well as for the calculus, that this is the last question, and after that I will upload the function video you can watch as well. So the question says the following information about a cubic polynomial y is equal to f of x is given. So now here f of -1 is equal to 0, which means this is the x-intercept we have. So this is the x-intercept, one x-intercept we have here, right? So the x value -1 and the y value 0. Then he say f of 2 is equal to 0. So this is second x-intercept, x value 2, y value 0. Then we have f of 1 is equal to -4. So which means x value -1 and y value -4. Now he say f of 0 is equal to -2, which means x value 0, y value -2, and this is gonna be your y-intercept. Now he say first derivative at x equal to -1 and the first derivative at x equal to +1 is 0. So these are your turning points, because the first derivative -1 at x equal to -1 and +1, they are 0. So which means this is your turning point, because x value 1, y value is -4. So this is your turning point, because there he say first derivative at x equal to 1 is 0. So by the turning point, first derivative is equal to 0, and the second turning point is going to be this one, because x is -1, y value is 0. So this is going to be your second turning point, because at x equal to negative 1, first derivative is equal to 0. So this is this x-intercept as well as your turning point. So we're gonna count these x-intercept twice. Now he say if x less than negative 1, then first derivative is greater than 0. So if x is less than 1, so if x, now he say if x less than negative 1, then first derivative greater than 0, which mean positive. So x less than negative 1, first derivative gonna be positive, and if x greater than 1, then first derivative is positive. So this is my x-axis, this is my y-axis. So like I said to you, in this case we have to, I always first sketch the graph, then I plot the points, but in this case we need to first plot the points because we can see where they are situated. So first we write the x-intercept. So the x-intercept say negative 1 and 0. So the negative 1 is here, and the positive 2 and 0, so I say positive 2 is here, and then y-intercept 0 and negative 2, so that is somewhere here, negative 2. And then the turning point at x equal to 1, the y value is negative 4. So 1 is here, say, so y value negative 4 is there somewhere. X is positive 1, y value negative 4. So we have all the information. Now we can sketch the graph. Don't forget, he say if x less than negative 1, the first derivative must be positive. If x greater than 1, first derivative also must be positive. Must remember at x equal to negative 1 is turning point as well, because the first derivative also is equal to 0 here. So we got two turning point, one is here, one is here. Now must remember, first derivative is positive when the graph is increasing. So the graph must increase, and must remember this is turning point as well at x equal to negative 1, turning point as well as x-intercept, so we're gonna count twice. So the graph obviously gonna decrease till this turning point, again increase. So this is my graph, you can see these are the turning points. So the graph is increasing, which means first derivative positive, and here also the graph is increasing, which means the first derivative is positive. So this is my sketch, this is the sketch of the graph. And obviously between negative 1 and positive 1, graph gonna decrease, because he say if x less than negative 1, the first derivative is positive, which means the graph is increasing. And he say also x greater than positive 1, the first derivative is positive, so which means the graph is increasing. So there we go, this is our sketch of the graph. Now the question say 8.2, for which value of xf is decreasing. So the math start left to right, the graph is increasing till this turning point, decreasing till this turning point, again increasing, so on. So here looking where the graph is decreasing, the graph is decreasing between these two turning points. So my answer will be negative 1, between negative 1 and positive 1. And obviously negative 1 and positive 1 are included. Whenever they ask you if f is increasing or decreasing, the both x value are included, both x value of turning points are included. So this is my final answer. 8.3, use your graph to determine the x coordinates of the point of inflection. Now we need to find the point of inflection. There is no equation, so the point of inflection we can use these two turning point. We take the midpoint of these two turning point, that will be my point of inflection. So the point of inflection x is equal to negative 1 plus positive 1 divided by 2. So the answer is gonna be 0. So which means This is my point of inflection. 8.4, for which value of x is f concave up? So now he say, where is the graph concave up? So my point of inflection, earlier we found x equal to 0, that is here. This is my point of inflection. Now we need to see where the graph concave up. This is graph concave down till the point of inflection, and from here the graph is concave up. So the graph is concave up. This one graph is concave up. You can see the graph is concave up. So answer will be x greater than 0, the graph is concave up, because x value is 0 here. The graph is from the point of inflection, we need to see the graph is concave up. So x greater than 0, graph is concave up. Please like and subscribe my channel. If you have any question, comment below. I will assist you. Have a nice day.